Previous video, we dealt with simple regression analysis. Remember the executive producer who was interested in the prediction power of advertising and record sales. So we found out that 33% of variation in record sales can be accounted for by advertising. But we also found out that 67% remains unexplained. So we decided to add new predictor variables. If you add new predictor variables, which means you have more than one predictor variables, multiple regression is to be used. If we are interested in constructing a complex model with several predictors, how do we decide which predictors to use? So you are there with your research, you have all these variables, but you don't know which one to include in your model. I can tell you this is your responsibility. SPSS will do what you tell it to do, but it will not decide instead of you. So a great deal of care should be taken in selecting predictors for a model because the values of the regression coefficients depend upon the variables in the model. So in an ideal world, predictors should be selected based on past research. It is very important that you read about the area and find out what variables have been proved to be important in past research. So new variables should be selected based on their theoretical importance. And so the method of predictor selection is crucial to your model. There are several methods of regression. Actually, in SPSS, there are three: hierarchical or blockwise entry, forced entry, and stepwise methods. So the hierarchical or blockwise, this is where the experimenter, so you decide in which order to enter your variables. A general rule is that known predictors should be entered to the model first in order of importance, and then you add the new variables. The second one, forced entry, is when all predictors are forced into the model simultaneously. So there is no order of entering. The third one is the stepwise methods, which, due to some mathematical drawbacks, should be avoided and only used in exploratory models. So if you have any previous knowledge on your variables or some of your variables, it is better to use the hierarchical entering. Yes. The question of generalizability, if you would like to generalize your model for different samples from the population, then some assumptions should be met. If the assumptions are not met, then you can only use your model for your sample. So if you would like to generalize to a larger population, then you should check for assumptions. And what are the assumptions? So the first one is the variable types. Your predictor or independent variable should be quantitative or categorical, and by categorical I mean only two categories. And the outcome or the dependent variable should be quantitative. Important. Non-zero variance means that each of your predictor or independent variable should have some variance in it. The third assumption is no perfect multi-collinearity. So the predictor variable shouldn't correlate too highly. Imagine that you would like to find out what are the variables that predict performance on a vocabulary test, and for example your variable of motivation and attitude correlate highly, then when interpreting your results you cannot really make a difference between the two, so you don't know which one predicts which one adds more to your model. So it's very important. Predictors are uncorrelated with external variables. What are external variables? External variables are variables that haven't been included in the regression model, which influence the outcome variables. So imagine you have 10 variables, you decide to include only 6, and you have your results, and then some of them have a predicting power, but later you find out that that variable and a predictor variable correlates with a variable that was not included in your model. So you better make sure before you do any regression analysis that your predictors, external or internal, do not correlate. Homoscedasticity, we will make our SPSS program to check for this. At each level of predictor variables, the variance of residual terms should be constant. So we have a method of checking for this. The next is independent errors. For any two observations, the residual term should be uncorrelated, and we will test this by the Durbin-Watson test, which should be around 2. So the Durbin-Watson test shouldn't be too smaller or too bigger than 2. Normally distributed errors. This assumption simply means that the differences between the model and the observed data are most frequently 0 or very close to 0. Independence, this means that the data comes from different participants, different entities. And linearity, it is assumed that the relationship we are modeling is a linear one. In this video, we will check for some of these variables, but not for all in a very detailed way, because that would mean a very long video, but you can find information about these assumptions on the internet. And the last word before trying it out in SPSS, it's about the sample size. So it is important to collect enough data to obtain reliable regression model. But how much is enough? There are several ways of checking for sample size, but I recommend you to use this graph as an important reference point. So your sample size depends or should depend on the number of predictors you have in the model and the sample size that you expect. So for example, if you have 6 independent variables or 6 predictors and you expect to have a large effect, then you have to have around 50 participants, a sample of 50. If you expect to find a medium effect, then you need to have 100 participants, or if you expect to find with 6 predictors a small effect, then you need to have more than 600 participants. Okay, let's try this in SPSS. Open the SPSS file record 2, and here you will see our previous dataset extended by other variables. Okay, yes. Okay, so here the record company executive was interested in extending the model of record sales to incorporate other variables. So besides the advertising budget, then the other variable, as you can see here, the number of times the record is played on Radio 1 during the week prior to release. So this is called airplay, so how many times the given record was played, and attractiveness of the band. This was measured on a scale from 0, which is not attractive at all, 10, very attractive, and the targeted audience were asked, and here the most frequently used attractiveness scale was used as a measure. Okay, and these are displayed in thousands, so 10.26 means 10,000, yeah, more than 10,000 sales or so in thousands. So to find out which predictor variables have the most predicting power, we go to analyze, regression, linear, as before. Our independent variable or dependent variable or outcome variable is still record sales. And then here, before we have previous knowledge about one of the variables, which is advertising budget, which predicted record sales by 33%. This comes from past research. We have theoretical background for it, so we enter this first into the model. And here we already discussed that there are several ways of entering your variables. We use the hierarchical or enter. So we've got the most important one. Then we go to the next level, to the next block. You can see block 2 of 2. And the new variables will be included, which is the number of plays and the attractiveness of the band. Okay, so we've got our model. Then we go to the statistics, and here there are several things that you can check. First, you've got the estimates. These are the regression coefficients, remember from the previous videos, which are the b values, the gradient, and the intercept, remember. And a t-test is also displayed to see whether these regression coefficients are significant. And then you've got the model fit. This provides a statistical test of the model's ability to predict the outcome variable. So this displays as the f-test, the simple r, which is the correlation, the r square, which is the percent to which the predictor variables explains the outcome, and the adjusted r square. Then you've got the r square changed. This is the r square resulting from the inclusion of a new predictor. And so it tells you how much the new predictor contributes to the model. And then the descriptives, it gives you the mean, the standard deviation, and the rest. But it also gives us a correlation matrix, which can be used to assess whether the predictors are interrelated, so whether there is a high correlation or not, which helps us to define whether there is a collinearity or not. Part or partial correlation of the predictor variables and the outcome variables, collinearity diagnostics, again, the relationship between the predictor variables, whether there is any. This is one of the assumptions, remember, for a generalizability. The Durbin-Watson test, this is the assumption for independent errors. And this is what we wanted. So you click on continue. And you also go to the plots. These are important because this helps us to check the assumption of homoscedasticity. So these are plots that will show us whether the data points are around 0 or they are skewed or something. So for a basic analysis, it is worth to plot S-recid on the y-axis against a z-pred for the x-axis. Then we go produce all partial plots as well, histogram normality. You go next, and the other basic analysis will be S-recit on the y-axis and Z-pred on the x-axis. So this would show us any heteroscedasticity, which is the violation of the assumptions. And then you go to continue, and we are ready. So on the new, we click on OK. And the results are all here. You can see this is the content of the analysis. First, you see descriptive statistics of the data. You can see that the mean record sales are 193,000. This is the standard deviation. It will be important later. And also the standard deviations will be important later, so it's good to keep it. The next, as I said, is the correlations. So you would like to see that your predictor variables are not correlated. They are different from each other. So what are the predictor variables? The advertising budget. We know it correlates with the record sales. That's the outcome variable. That's not important. It correlates with itself. Fine. But the correlation with the number of plays on radio per week is a very low one. It's 0.1. So we say that there is no collinearity in this case. And with the attractiveness of the band, it's again very low. So you can take a deep breath. The correlation matrix is just fine. The next is the model summary of the model. Remember that we chose a hierarchical entry, so that gives us a different steps, different stages in the hierarchy. So model 1 is the first stage, model 2 is the second stage, and here you can see the R, which is the multiple correlation coefficients between the predictors and the outcome. Both of them are positive. The R square, which is how much of the variability in the outcome is accounted for by the predictors. Remember that when we used advertising budget only, it accounted for 33.5% of the variation in the outcome in the record sales. Now that we added two more, the attractiveness of the band and the number of plays on Radio 1 per week, accounts for 66.5% of the variation in the outcome, so it explains 66.5% of variation. And what else? The adjusted R square. This should be as close as possible to the R square, because it shows us how well the model generalizes to the population, and we are very close to the R square, so we are happy. And the important value here is the Durbin-Watson test. Remember, this should be as close as possible to 2. Here we have a value of 1.9. So this was the assumption of independent errors, and we can say that the assumption of independent errors is met. It's not violated. The next table is the ANOVA. This should be familiar for you from the simple regression analysis. We already discussed this first part when we only use the advertising budget. Now we are going to discuss the second part of. So we can conclude, as you can see, that the F value increased insignificant, we can conclude that the initial model significantly improved our ability to predict the outcome variable, but the new model with 2 extra variables was even better, insignificant, which, remember, is different from the model of the mean. Okay. The next is, yes, the model parameters, which is the coefficients. Okay, so the b-values here tell us about the relationship between record sales and each predictor variable. So if they are positive, then the relationship is positive. If they are negative, then the relationship is negative. So we can say that the more it is advertised, the more advertising budget, the more record sales. If the number of plays on Radio 1 per week increases, the record sale increases, etc., etc. But they also tell us, these b-values, to what degree each predictor affects the outcome, if the effects of all other predictors are held constant. For example, if you look at the advertising budget, which is 0.085, so if we increase this by 1 unit, then the record sales will increase by this number. Remember that this variable, both variables were measured in thousands. So if you increase the budget by £1,000, then that means 85 extra records. Number of plays on Radio 1. So every additional play on Radio 1 means 3,367 new sales. And if you increase the attractiveness of the band by 1 unit, that means 11,086 extra sales. Okay, the next is the beta. We take this as a better measure because the standardized versions of the b-values are easier to interpret. So these are the standardized versions of the b-values. They are easier to interpret because they are not dependent on the units of measurement of the variables. Okay, so these are easier to interpret, and we use this also to report on our results in our study, for example. Yes, this means that the number of standard deviations, the outcome will change as a result of one standard deviation change in the predictor. You will understand it soon. So look at these beta values. You see that the advertising budget is 0.511, number of plays on random, so they are very similar to each other, and this is different, the attractiveness of the band. So how do we interpret this? Advertising budget, you could see that the standardized beta value is 0.511. This value indicates that as advertising budget increases by 1 standard deviation, where can we find the standard deviation of our data? It's in your descriptives. So look, the record sales standard deviation is 80.699. The advertising budget standard deviation is 485.65. Number of plays on Radio 1 here. So this is the first table in your output. So going back, it will be easier to interpret. So this value indicates that as advertising budget increases by 1 standard deviation, as you could see, this 1 standard deviation increase means 485,000 pounds. Record sales increased by 0.511 standard deviations. So the standard deviation for record sales is, as you could see, 80.699, and so this constitutes a change of 41.240 cells. So does this value, where does this value come from? So you multiply this beta value with the standard deviation of the record sales. So what does that mean? Therefore, for every 485.655 thousand pounds more spent on advertising, an extra 41.240 records are sold. And it's important, this interpretation is true only if the effects of attractiveness of the band and airplay are held constant. And you do the same calculation for the other predictors as well. Okay, going back to our output. Okay, the last but one thing we would like to check is whether the collinearity, the assumption of collinearity is really met. So for that we have to check these two values, the VIF, which should be smaller than 10. This is definitely smaller than 10, and the tolerance should be bigger than 0.2. This is bigger than 0.2, both of them. So we can say that this assumption is met. And finally, we would like to see normal distributions here. The dependent variable is normally distributed, as you can see by both figures. And this is homoscedasticity, which means that these data points should be dispersed around 0. So you have 0 here, and these are dispersed around 0. Shouldn't take any kind of linear form, right? Same here. And as for the so we can also say that the assumption of homoscedasticity is met. As to how to report on this outcome, you can check APA style, American Psychology Associations. Okay, that's it. Thank you.